retired headmaster from Vijay High School, which is located in Jayanagar 3rd block, Bangalore. I have served in the mathematics faculty for 36 long years and I retired about 5 years back. This is my 41st year of teaching and practicing secondary school mathematics. Today we will discuss one of the important chapters of our 10th standard mathematics. It is chapter number 4, circles. Yes, children, you can observe in this tabular column the entire statistics of this chapter number 4, circles. As you can see here, there are only two important theorems on tangents to a circle, for which there are 17 problems are there in our exercise, and there are 2 exercises are there with 3 problems, worked examples. Okay. So, altogether you have about 20 problems on these 2 theorems. Now, let us try to understand these 2 theorems now. Here is a circle, here is a line segment, you can call it as AB. This is called a chord, C-H-O-R-D, chord. Okay. Here is another straight line. So, let us name this as CD. It is a straight line which is cutting the circle, the circumference of the circle at 2 distinct points. It is called secant, S-E-C-A-N-T. Here is another straight line called say PQ, which is touching the circle at only one point. Here it is R, and this straight line is called as the tangent. So, today we are going to understand 2 important fundamental theorems on this tangent, and this or the pointer is called the point of contact. Okay. Now, look at this line segment. Let us call it as XY. Can you call this as a tangent, children? This is touching, can you say that it is touching at Y? No, because if you extend this, if you were to extend this line, it will cut this circle at another point. Therefore, it cannot be called as a tangent, it is a secant. So, tangent means a straight line. However you extend on either direction, it will touch, it should touch only at one point, and such a straight line is called as a tangent. Okay. Now, this cannot be called as a tangent, because when extended this on this side towards the right, it will intersect at one more point. So, therefore, here are the definitions for the 3 concepts. First of all, chord. Chord is a line segment which joins any 2 points on the circumference of a circle. You can take any 2 points on the circumference, join it, the line segment is called the chord, and you know the diameter is the longest chord. Now, secant. Secant is a straight line, chord is a line segment, whereas secant is a straight line which cuts the circle at 2 distinct points, separate points. And finally, tangent is nothing but it is a straight line which touches the circle at only one point, and the point is called the point of contact. So, these are the definitions for a chord, secant and a tangent. Okay. Now comes the 2 fundamental theorems on the tangents to a circle. There are only 2 theorems are there given in our textbook. Let us try to briefly revise these 2 theorems now. Okay. Let us take the first theorem. In our textbook it is called 4.1. This is not universal. So, far as our textbook is concerned, this comes under 4.1. Okay, the statement, general enunciation. In a circle, radius and the tangent at the point of contact are perpendicular to each other. This is the statement. This is called general enunciation. So, in any circle you draw the radius and draw the tangent also. At the point of contact, you can see that the tangent and the radius are always mutually, they will be perpendicular to each other. Now, we have to draw a suitable figure for this. So, with the help of compasses, you draw a circle with some convenient radius. As far as possible, take 3 centimeters or maximum 3.5 centimeter and draw a circle like this. Okay, locate the center of the circle, call it as O. Okay, now here is a straight line. So, 2 arrow marks on either sides indicates that it is a straight line. Let us call the mark any 2 points on it and call them as one as A and another as B. Now, this straight line, you can see from the figure, it is touching only at this point. Okay, let us call it as C. Now, let us write down the data, whatever given, let us write down, list down. So, the first point is O is the center of the circle. Okay, the second point is, look, this is the symbol for straight line. So, write AB on the top, you draw a line segment with 2 arrow marks on either side, read it as straight line AB. Straight line AB is the tangent where it is at C. So, C is called the point of contact. And now, join O and C. So, OC will become the radius. Okay, this is the data portion. So, by reading the theorem, the general enunciation, we should be able to write down the whatever given as per this figure only. So, having written the data, now we have to find out what is to be proved, what is to be established. So, we need to show that, we have to prove that this radius and this tangent at this point of contact are perpendicular to each other. Look, this is the symbol for perpendicular. Okay. So, OC is perpendicular to AB. Children, if you want to prove this, we need the help of some prerequisites. So, whatever we have learned in our lower classes, say 8th, 9th and before the first term. So, all these things will be so much helpful to understand this. So, let us try to understand whatever prerequisites are there in order to prove this particular theorem. So, we need the help of another important theorem. The statement is this: out of all the straight lines that can be drawn from an external point to a given straight line, the perpendicular is the least. Okay, this is the statement. So, you draw a straight line like this. Okay, here is a straight line, call it as AB. Okay, now mark an external point some anywhere here, anywhere very close to this or left or right or even below, anywhere you want you can locate this point. So, you can just name it as the point P. So, P is the external point and AB is the straight line. So, from P you can draw so many line segments like this. So, a few have been drawn here. This is one. So, let us call it as PC. This is another one. So, let us name it as PD, and PQ is actually perpendicular to AB, and on the right also, for sample, let us draw few more lines, say PE and PF. So, these are some of the line segments we can imagine from this point P to this straight line AB. Okay. Now, the theorem states that out of all these straight lines, so many lines that we can draw from this point P to the straight line, which one is the least distance? The theorem states that, so among these there will be only one line segment which will be perpendicular to AB from P, and that perpendicular is the shortest distance, is the minimum distance. So, PQ is perpendicular to AB. You children, you know that this is a symbol for